Okay, so I've talked about one set of random topics already, and now I'm just going to talk about another set of random topics. These are totally random topics that I hope will help you for your trial paper. Okay, so this is set 2 of my random topics. All right, now the first thing that I would like to talk to you about is between vector and scalar. Okay, so our physical quantities, meaning things that we can measure, okay, we can split them into vector and scalar. Now, scalar means it only has magnitude. Magnitude means the number, how much, okay? Let's say 5 meters, yeah? But vector is something that has magnitude and direction, okay? Vector is something that has magnitude and direction. For example, 5 newtons to the right, okay? So this is the difference between scalar and vector. You should look up some examples as well. You should remember what examples are scalar, what examples are vector. Okay, the next thing I would also like to talk a little bit about the photoelectric effect. Now, again, I have not covered this in class yet, but this is just a little tip for you all. If let's say they ask you, what are the conditions for it to occur? Okay, in order for photoelectric effect to occur, either your energy of photon, okay, either the energy of photon must be at least equal or more than the work function. Okay, you can remember it like this. The energy of photon must be more than or equal to the work function, or you could say the frequency of light must be more than or equal to the threshold frequency. Okay, the threshold frequency. So these are the minimums for photoelectric effect to happen. Now, speaking of this topic, if let's say they ask you to calculate the energy of a photon, okay, this I've covered in class already. The energy of the photon is either equals to HF or it is equals to Hc over lambda, okay? So H, it is the Planck's constant. It is a fixed number. It will be given to you, Planck's constant. F is the frequency of the light, okay? C is the speed of light in vacuum, meaning 3 times 10 to the power of 8. And lambda is the wavelength of light. So depending on what information they give you, you have to choose the correct formula to use. Okay, the next thing that I would like to talk about is on diodes, okay? So for diodes, it is actually something that allows current to only flow in one direction. They might ask you about this, okay? So the function of a diode is to allow current to flow in one direction only. Okay, is to allow current to flow in one direction only. Now, if let's say they ask you, how do we use this in a circuit? Okay, so we can use it to do a process called rectification. What is rectification? The meaning of rectification means to convert AC, that is alternating current, into DC, that is direct current. Okay, that's how we use it inside the circuit. If you want to convert AC to DC, there are 2 ways to do it. The first way is to just take AC, you have one diode facing in one direction, okay, so that when the current goes this way, it will go through, but when it go the other way, it doesn't go through. So end up, right, this is what you will get in your graph. Like that. Okay? Because this part, the bottom part of a normal AC graph, the bottom part is missing already. The bottom part is the part that cannot get through the diode. Okay? So that's why we don't draw the bottom part. But if there is a more complicated version, okay, whereby you have like 4 different diodes, okay. Now, to draw these 4 diodes is actually very simple, yeah. You just need to make sure that the opposite diodes are the same direction. This and this are the same direction, okay. Yeah, this and this are in the same direction. This and this are in the same direction, okay. And when you run through the circuit, right, you will notice whether it will make sense or not one, okay, if you draw it like that. So when you get this kind of diode arrangement, this is called full wave. This one was half wave, sorry. This was half wave rectification. And this one is full wave. And you will end up getting this kind of graph. Like that, like that, like that, like that. Okay? Originally, the part that went to the bottom now became on top. Okay? It is now in the same direction because DC can only have one direction. So that's what we are doing. We are trying to change the opposite direction back to the same direction. Okay? So full wave rectification and half wave rectification. All right, the next thing that I'm going to talk about is centripetal force or centripetal acceleration. Now, F equals to mv squared over r. That is the formula for centripetal force. I think this is given in the formula sheet. Now, if they ask for centripetal acceleration, it's very simple. You know that F equals to ma, right? So this must be the A. Yeah, because F equals to ma. All right. So the A, the centripetal acceleration, is v squared over r. Okay. So all you have to do is just find the information that you need and put it into the formula. All right. The next thing that I want to talk about is magnifying glass. Now, magnifying glass is always done with a convex lens. It has to be done with a convex lens, okay? And the criteria is that your object has to be very close to the lens, okay? In fact, it must be, how close? Must be shorter than the focal length. It must be between the lens and the F. Doesn't matter where, but as long as within this range, you will get the magnifying effect. Okay, if you draw your ray diagram straight to F and then one more through the center, you will realize that you have to trace your lines back to get your final image. And the characteristics of the image, it will always be virtual because you see it inside the magnifying glass. It will be upright. Nobody uses a magnifying glass and turn upside down to read. And it will definitely be magnified. That's the whole point of the magnifying glass. Okay? These are the characteristics of the image for magnifying glass. All right? Must be using convex lens. Okay, speaking of this, you can calculate the focal length using this formula. 1 over F equals to 1 over U plus 1 over V. Just be very careful. If it is a convex lens, yes, the F is positive as usual. But if it is a concave lens, the F must be negative. If the image is virtual, it must also be negative V for this. Okay? Yeah? Other than that, it's positive. U, the object, will always be positive. It's always real. Okay? That's how you calculate the focal length using the lens formula. Okay, for the next topic, let's talk about electric power. Okay, electric power. Now, doesn't matter what it is, but for electricity calculation, you can usually survive with V equals to IR, P equals to IV, and E equals to PT. Normally, if you know how to use a combination of these formulas, you can get all the calculation done, almost all the calculation done. Okay? And remember, when we choose wires, okay, for material, copper wire is the best because it has the low resistance. And we like to have low resistance in our wires because it saves energy. it doesn't waste energy as heat. Okay, so we love to have low resistance, which means our wires need to be as wide or as thick as possible and as short as possible. Okay, that will help with low resistance. Unless you want to make heat. If you want to make heat, then you want to have high resistance. That is the only time we need high resistance wires. Okay, the next thing that I want to talk about is half-life, specifically the calculation. So remember, half-life is how long does it take for something to half, for the radioactive thing to half. So if let's say there used to be 100 grams, okay? After one half-life, it will be 50 grams. After two half-life, it will be 25 grams. After three half-lives, 12.5 grams. So on and so forth. Okay? So if they tell you, let's say, the half-life of something is 2 years, just an example. Then they ask you, how much is left after 4 years? Then you got to find out. After 4 years is actually 2 half-life already. So you half one time and then you half a second time. Okay? Or let's say they tell you from 100 all the way to 12.5. This whole thing took 70 days. Okay, let's say this whole thing took 70 days. So what is the half-life? So what you need to do is you have to keep halving. 100 half becomes 50, 50 half becomes 25, 25 half becomes 12.5. So how many times did you halve? 1, 2, 3 times. So 70 days is 3 half-life. Then 1 half-life will be 70 divided by 3. And then you will get your answer for half-life. Okay, the next one, I'm going to talk a bit about some essay questions, particularly maybe some about momentum. So for momentum, right, there could be a few choices. There could be water rocket, there could be jet engine. I think these are the more common ones, right? Water rocket and jet engine, okay? So a few things that you might want to keep in mind. So for example, the shape should always be aerodynamic. Aerodynamic will reduce air resistance. It can make it fly further, okay? You want a small nozzle. Small nozzle can shoot out the gas, can shoot out the water at a higher speed, higher velocity. So it will produce a bigger momentum, okay? If you have to choose combustion chamber, definitely big combustion chamber. Okay, big combustion chamber. This is for the jet engine so that you can produce more hot gas. Okay, and for the water rocket, maybe they might ask you whether you need some fins on the side. Definitely you will need some fins to make it more stable when flying. Okay, yeah, some fins on the side. Now for spring, you must first identify what kind of spring do you want to get. Do you want stiff or do you want not stiff? Okay, so different reasons, different conditions, you might need different kinds of spring. If you want it to be stiff, it needs to be thick, it needs to be short, and it needs to be small diameter, as in the coil diameter, the circle itself. Okay, all this will give you a high spring constant, which means it will be stiffer. So not stiff will be the exact opposite. It will be thin wires, it will be long, and it will be big coil diameter. Okay, that's for a not stiff spring. The next one is pressure. Now for pressure, because there are too many kinds of questions they might ask you already. So it's a bit hard to tell what kind of pressure questions there are. Okay, so maybe if they ask for hydraulic jack, let's just say, I'm just gonna go ahead and just mention a random one. Okay, so if they ask for hydraulic jack, yeah, remember we gotta use a liquid on the inside. Cannot use gas because gas can be compressed. Liquid cannot be compressed. Okay, if you're gonna choose between the liquid, oil will be better than water because oil can serve as a lubricant. Okay, oil can be a lubricant, meaning it will make the piston move smoothly. Okay, but liquid always cannot be gas. The output area must be greater than the input area. This is a definite must also. If your output area is small, you will actually get a smaller force than what you put in. Okay, so the input is small, the output is big. So that you put in a small force, you can get a bigger force on the other side. Now, the last one, modifications to keep your house cool. So, cool house, you can consider using high specific heat capacity materials. Okay, high specific heat capacity materials, because that means it won't heat up easily. Okay, it can take a lot of heat, but it won't heat up easily, right? You can consider having larger windows. Larger windows will provide more airflow. You can consider having shiny paint on the outside, shiny or white paint on the outside, then it would reflect heat. Okay, it will reflect heat. For the roof, also you can use high specific heat capacity roof. Okay, high specific heat capacity roof. All right. And yeah, that's what I can think of right now. Okay, so depending on what kind of criteria they ask you to give answers for, then you just answer accordingly lah. So remember, for essay, you can draw a table and you need 10 marks in total. Okay, so normally the ones that have choices, you will choose 4 things and then 1 final choice with the reasons. For this kind of design questions, you will have to give 5 different things, 5 different modifications. All right. So again, these are just random topics. Okay. Nothing specific about these topics. But I hope they will help you in your trial exam. Okay. Good luck.